In this video, we are going to solve the Leetcode problem of the day, and the problem is count the number of ideal array. The problem category is of hard level, but I would say once you know the maths behind this problem and once you understand the dynamic programming solution of this problem, this is going to be super easy to understand as well as code. Both of this is going to be covered in this video. The input given in this problem is an integer n and another integer max value. The output which we need to give in this problem is the number of distinct or the number of unique ideal array of length n. This n is given in the problem itself, or I can say the input. And what is this ideal array? Let me explain you. Let us imagine a situation that the value of n is 6. Then we need to create ideal arrays, right, of length n. So let us imagine that this array is ideal. It has 6 elements a, b, c, d, e, f. That's given here, right? That the ideal array of n length we need to create. And how can I say this is ideal? If each of the element can be divided by its previous element. Okay. For example, if this is my array and b mod a is equal to 0, c mod b is 0, d mod c, e mod d and f mod e, all of these are 0. It means that b can be divided by a, c can be divided by b, d can be divided by c, e can be divided by d and f can be divided by e. This is the first property of an ideal array. The second property is the range of values for the a, b, c, d, e, f. That is, the range of values of these elements is going to be from 1 to max value. This max value is also given in the input. So from here I can say that any array is called an ideal array of length n if all the elements are within the range of 1 to max value and all the elements can be divided by its previous element. We are not going to check this divisibility property for the first because we do not have a previous element for it. But for other elements, it should be divided by its previous element. Now, if we believe this divisibility property, then basic mathematics says that a should be less than equal to b, b should be less than equal to c, c should be less than equal to d, d should be less than equal to e, and e should be less than equal to f. That is, your array should be non-decreasing, and that's because if I say that b is 4, then a cannot be more than 4. You can try this, right? If I put b as 4 and a as 5, 4 can never be divided by an element which is less than 4, right? So 4 can be divided by 4, or 4 can be divided by 2, 4 can be divided by 1, but 4 cannot be divided by 5, 6, 7 or anything which is more than 4. So if we believe this first property, then we can say that each of this element is either going to be equal to the previous element or more than that. So this array has to be non-decreasing. Now how can we solve this particular problem? See, the thing is, now if this divisibility property is not required, let's say this divisibility property is not required, then in that case this question is very easy to solve. See, what we can do is we have to create some number of arrays of length n, right? Those should be ideal. And now if I say that we don't need this property and we just believe one property that the values should be from 1 to max value, then I can simply say that if you need to create an ideal array of length n, then in the first place you can fill, what are the values you can fill? It should be 1, 2, dot, dot, dot till the max value, right? In the second place also I can put from 1 to max. In the third also I can put 1 to max. So I can say the output will be max multiplied by max dot 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 multiplied by max. That is max value given in the problem to the power n. That's because for each of the number or for each of the position, I have total max value as the number of possibilities which I can put. For example, if the max value is 3 and the ideal array should have a range of the values from 1 to max value, so it should be 1 to 3, right? So every element can either be 1, 2 or 3. All the elements can either be 1, 2 or 3. So there are 3 possibilities for all the elements. So 3 multiplied by 3, 6 times, right? So this is actually 3 to the power 6. That is 3 to the power n. Now, this is something which will happen if this property is not satisfied. But we need to satisfy this property as well. Now we need to do this a bit smartly, right? We cannot just brute force it. For example, we cannot produce all the arrays which is possible with this max value range. And then we can just check, hey, all the elements should be divided by the previous element. If that is true, I am going to count that array. This can be brute force, but this is not going to work. So let me explain you how can we solve this with this example. If n is 5, max is 3, that is the maximum value allowed for each of the place in my array is 1, 2 or 3, right? The output is going to be 11. It means we can create 11 arrays of length 5 such that all the elements will be dividing the next element, or I can say all the elements should be divided by the previous element and the values will be ranging from 1 to 3. What I am going to do is I am going to fill one place at a time. Okay, what I will do, I will first analyze what are the possibilities which I have. It's 1, 2 or 3, right? So if I put a value 1 over here, that is if I put the last element as 1, then none of the element before this can be 2 or 3 because the array is non-decreasing. So if this is 1, then the previous elements can be 1 or less than 1, but the possibilities are 1, 2 and 3, right? So in this case, if I put this as 1, the other elements has to be 1 and this is the one array I can create. Out of this 11, this is also one array, okay? This is an ideal array. What if I put this value 2 over here? If this is 2, then I can either put 1 or 2 in the places, right? I cannot use this 3. So what I'm going to do is I'm just going to put one value here, either 1 or 2 or 3, and then I will see what are the possibilities for the other values. So I can say I need to create a function which will accept two values. The first is the last value which I am putting in my array, and the next value is how many allowed unique values do you want in this array. I will tell you why this is very important. Okay, so for example, if I put 1 here, then in this array I just have one allowed value, that is 1. I can just put 1 here, right? But if I put 3 here, then I can either say 1, 2 or 3. I can choose any values. I know that I have to make sure that each of the element should be divisible by the previous element, but I'm just saying that if I put 3 here, then the possibilities are 1, 2 and 3 before this, right? We are surely going to make sure that none of the property of an ideal array is violated. So what we are going to do is, we are just going to put 1, then we are going to put 2, and then we are going to put 3 here. That is, all the possibilities is something we are going to put here, and every time we are going to start by saying that we will just allow one unique value. Okay, so if I put 1 here, I will say okay, other elements can have just one unique values which I have already put. If I will put 2 here, then I will say other elements can only be 2. If I put 3 here, then the other elements can only be 3. This is something we are going to start with. Okay, we are going to cover all the cases. Okay, I am going to create a function which will accept a value last and allowed unique values. The last is the last element I am putting here, and the allowed unique is the number of unique values I want in my array. Okay, I am going to call this function 3 times, or I can better say that I am going to call this function the number of times the possibilities I have. So I have 3 possibilities in this particular input. So I will call this function 3 times. It will be 1, 1, 2, 1, 3, 1. Whatever result I am going to get from all these functions, I am just going to add the result, and that is going to be the output. We are going to recursively call this function, and then we are going to check for other cases as well in which the allowed values are going to be more than 1 or 2 or 3, right? So first of all, if I just say that I call this function with 1, 1, then my last element is fixed as 1. Okay, so this is 1 for now. Now if this is 1 and I am saying that I will just allow one unique value in my array, so what are the possibilities of other values in my array? So the question is, how many ways can I fill the other values with the maximum value for now is 1, right? Because the last value is always going to be the maximum, because the order of our array is non-decreasing. So this should be non-decreasing and not increasing, I would say, because the elements can be equal as well. So better I would say that the order of the elements is going to be non-decreasing. Now there is a straightforward formula for this, and I'm going to first tell you what is the formula, and then I'm going to explain you when this formula is applied. See, first you need to identify how many spaces or how many places you need to fill. If you are fixing the last element every time, because this function accepting a value which it will fill in the last place, then how many places more do you need to fill? The remaining places, right? So if I have n elements, I have to fill n minus 1 elements because I am fixing my last element. So I have n minus 1 c. This c is combinations, and then what is this? This is possibilities minus 1, or I can say allowed unique values which I have minus 1. And I am going to tell you why this minus 1. Okay, now imagine a situation that you put the last value as 4, and you say that I have 3 values which I can fill in this array. Maybe those values are 1, 2 and 4. Then if I ask you how many ways can you fill the other elements, the other 4 elements, if you have these 3 values which are allowed, forget about the case that it should be non-decreasing. Then you will say that okay, then it is NCR. N will be 4, the number of places I have to fill. C, R is the number of items with which I can fill those places. 4C3, right? I can say n minus 1 is my n here because I have these many places to fill. N minus 1, C, possibles, minus 1. Now why this minus 1? This is because I need to make sure that my order should be non-decreasing. If this condition was not there, I could say n minus 1, C, possibles. But if I want to make sure that whatever elements I have, I want to make sure that my order is non-decreasing and my array should include all these 3 values at least once, then the formula should be n minus 1, the number of places which I have to fill, combination C, and possibles minus 1. This minus 1 is to make sure that the order will be non-decreasing. That is, we will choose only those arrays in which the order is non-decreasing. This is a mathematical formula, you can say, so you just need to make sure that you remember this formula. So if we are fixing the value of 1 here, we have 4 places to fill. 1, 2, 3, 4. 4C, 0. 0 because we have total 1 possibilities in this case, right? We were calling this function with 1, 1. So I would say 4C0, it means 1. 4C0 is 1. So if I put 1 here, I just have one possibility to fill my array and get an ideal array in which the number of allowed unique values are 1. Now next what I am going to do is, I am going to say what is the next multiple of this 1. For now I am putting 1 here, and right now I am not processing this 2, 1 or 3, 1. We will process it, but not now. If I am saying that what is the next multiple of 1, that's our last element. So next multiple of 1 should be 1 plus 1, right? 1 plus 1 is 2. That's the next multiple of 1. So I would say instead of 1, I would put 2 in the last place. Okay. And when I put 2 in the last place, I would say that my number of possibility is going to increase. It was 1 earlier. the number of allowed unique values. Now it is going to be 2. We can fill the other elements with 2 elements, 1 and 2. Now we need to apply the same formula. Our function call is 2 comma 2. This 2 means that the last element I have to put. This 2 means that I have 2 unique values to fill, 1 comma 2. And my formula is going to be n minus 1 c p minus 1. P is the possibilities I have. I have 2 possibilities, 1 comma 2. So 4c1, because n is 5. So the formula will be 4c1. We have to fill 4 places, and we have to fill those 4 places with 2 unique values, 1 comma 2. But I have to make sure that the values are non decreasing. So the formula is 4c1, that is n minus 1 c p minus 1. 4c1 is 4. It means that if I put the last value as 2 and the other values should have 1 or 2, at least 1 1 and at least 1 2, right? That is, both the elements should be included. You cannot say all the values are 2, right? We are going to cover this case separately. So if this is 2 and the other values are 1 2 2 2, or you can say 1 1 1 2, something like this, then you have 4 different possibilities. What are those 4 possibilities? Let me show you. This is 2, right? So I can say this is 1, this is 1, this is 1, and this is 1. Our array is having 1 and 2 both, right? Or I can say this is 1, this is 1, this is 1, and this is 2. 1 1 2 and 2, and this is 1 2 2 and 2, right? This 2 will continue in the last. Now these are the 1 2 3 4 possibilities we have. If we put the last element as 2 and the other elements as either 1 or 2, then again we are going to do the same thing. What is the next multiple of 2? Last time we checked the next multiple of 1, right? The next multiple of 2 is 4, right? So we can say 2 plus 2 is 4, right? So what we can do is we can put the last element as 4. But the moment we put the last element as 4, I don't need to process further, because the maximum value allowed in this problem is 3. So the moment we reach to this 4, I can say this is not valid. I don't need to process it. But in case if we process this, this will look something like this. The last is 4. The other values, we have 4 values to fill, and I can fill those values with 1, 2, and 4, right? So I should be making a function call with 4 comma 3. 4 is the last element I have to put. 3 is the number of unique values we are going to use. 1, 2, and 4. This is always going to increase. Okay. Earlier we were using with 2. Before that we were just having 1. So this is going to increase. So this is how we are doing recursive calls and increasing the number of possibilities. And this is going to cover all the cases. Now what is n minus 1? This will be 4. What is the p minus 1? P is 3, right? We have 3 possibilities. So p minus 1 is 2. So I can say 4c2, which is 6. So in case the 4 would have been valid, we would have 6 different ways to fill 1, 2, and 4 in this particular array, such that the last element is 4 and the array is made up of 1, 2, 4, and the array is following all the property of an ideal array. Now we know that this is not valid. So we are going to come back to the recursive call. So the processing of 2, 2 is done. We will come back again. This was 1, 1. Now what we can do is we can just see the next multiple of 1, which we have not seen. So we have seen this 2, which was 1 plus 1. We can say 1 plus 1 plus 1. That is 3. That's the next multiple, right? So this time I'm going to make a function call with 3, 2. That's because I'm setting my last element as 3. Okay. And I have 2 possibilities, 1 and 3. Okay. If I have 2 possibilities, the last element is 3, n is 5. So what is the formula? I have to fill 1, 2, 3, 4, 4 places, right? So the formula is n minus 1 c p minus 1. So n minus 1 is 4, c p minus 1, p is 2, right? The number of possibilities are 2. So I would say 4 c 1, that is 4. So if I put 3 here, I have 4 more possibilities of creating an ideal array. Okay, so we have got 4 plus 1 we already got, right? So we have got total 9, right? The output for this input is 11. We will see what are the other 2 ideal arrays. But what we can do now is we can check that can we go after this 3? Yes. What is the next multiple of this 3? It is 6, right? 3 plus 3 is 6. If I put the last element as 6, this is outside of the range. We don't need to process it. We will go back to our recursive function call, which was 1, 1 here, right? Now with this one, we tried with 2. We tried by putting 3. Next, what is the next multiple of 1? It is 4, right? So what we can do is we can put the last element as 4. But the moment we put the last element as 4, that's outside of the range, right? So we will come back. And once we come back, we are actually coming back to this original call, right? So after calling this, we got around 9 data, right? Now, if I call with 2, 1, what are we going to get? It will look something like this. So this is the last element, which is 2, right? We are calling this with 2, 1. It means that this is my last element, 2, right? And I have just one possibility in this array. That is, I will fill all my elements with 2 only. So in this case, if I put this in the formula, I will have n minus 1 is equal to 1, 2, 3, 4. C, and what is p minus 1? It is going to be 1 minus 1, right? I have one possibility, 1 minus 1, so it will be 0. So 4, C, 0 is equal to 1. So we just have one possibility. The last element is 2 and all the allowed unique values are 2, which is 2, 2, 2, 2, 2. This is my ideal array. And then I will try with the next multiple of 2, which is 4, and I will come back because 4 is out of our range. So what I will do is I will say for 2, 1 we got 1, and similarly for 3, 1 also we are going to get 1. So 9 plus 1 plus 1 is 11, and that is the answer for this particular input. So now let me take you back to the code editor and let me show you how we can solve this using Python. This is the complete solution for this particular problem. We have just created a main DP which is equal to a dictionary. That's because we just need to make sure that we store the result of any computed combination of current maximum and maximum possibles. And what we are going to do is we are just going to take the sum of the function call. We have created a function named as DP which is accepting two values, the current maximum, that is the last element we are going to put, and the maximum possible elements. Okay, so initially the maximum possible elements will be 1 and the current maximum will be 1, 2, 3 dot 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 till the max value. So we are just running a loop and we are calling this DP function, creating an array out of it, and then taking the sum of this. And also we are taking the mod of this complete value with 10 is to power 9 plus 7, that is mentioned in the question, that since the answer can be very large, return it with the modulus of 10 is to power 9 plus 7. Now coming to the main logic, we are first checking that have we already solved a problem of a combination of current maximum and maximum possibles. So anytime we solve a problem, anytime we solve a sub problem, I would say, with a current maximum and maximum possible value, we are going to store it in our main DP dictionary. So if we have this value, if we have this combination, we are just going to return it from our DP table. If we do not have, then we are just going to find out NCR value, that is the formula n-1 CP-1. We are just going to use math.comb function. N-1 is what we are going to pass, then maximum possibles minus 1, then that is going to be the result. Then what is my next element which I need to put in the last? That is going to be the current maximum plus current maximum, because we need to find the next multiple of current maximum. Now if the maximum possibles is equal to n, that is if you have reached the limit of maximum possible values, or if the next value, that is the next multiple of your current value or the current maximum value, is more than the maximum allowed values, we don't need to process further. We can directly say return the value of this result. But if this is not, we need to process, right? So we are going to do the processing with while loop, and we are going to say till the next value is less than or equal to the max value, because we don't need to go outside of the range. And if we are inside the range, we can try with the next value. So till the next value is less than or equal to the max value, we are going to say result is equal to result plus another DP function call with the next value as my last element in my array. And this time I'm going to increase the number of possible values. And then once this is processed, I'm going to check with the next multiple of my element. For example, if I started with 1, I would check with the next multiple of 1, that is 2 here. And then I'm going to make the next as 3, so that I can again check with my next multiple, which is 3, then 4, then 5, till we don't exceed this range of max value, right? And once we are out of this, we are just going to update this in our DP table. So main DP with this particular combination of current maximum and maximum possible is equal to the result, and we are going to just return the result. So once you know the logic which I have explained you in this particular video, this code will be simple to understand. So if there is any doubts related to the logic, you might find this solution a bit confusing. So make sure that you clear all your doubts, all your theoretical doubts, and then you jump on this coding part. So once you submit this code, you will find that this is actually a very efficient solution for this particular problem. So yes, you can see runtime is good, memory wise it's good as well, and I would say you don't even need a DP table. I'm just using it to make sure that my runtime is good. But what you can do is you can just ignore this DP table and don't need to store the result. You can remove this logic of checking your result from the DP table, and every time you can just create your result. This is also going to work, and you will see that the memory is really good in this case. But the problem is the runtime will be bad. So just to balance the runtime and memory, I'm using this DP table. You can choose to use it or you can ignore to use it. So you can see the memory is 100% right now, but the runtime is too bad, right? So I would say that's it for this video, guys. And if you got the understanding of the problem and the solution as well as the approach and thought process, then make sure that you hit that like button. And if you have not subscribed to my channel, then make sure that you subscribe to the channel as well. And I will see you guys in the next video.